In this video, we're going to look at using algebraic manipulation, mainly factoring, in order to find limits. So we previously saw this limit does not exist. If I tried to just plug in the value 3, I get 3 squared minus 9, or 3 minus 3 is 0 over 0. And we can't divide by 0, so we don't know the value of this limit. However, with a little bit of algebra, we can find the value of this limit. All right, to see why, let's just look at this graph comparison. So on the left-hand side, we have the graph of x minus 1 divided by x minus 1 times x plus 1. On the right, we have 1 over x plus 1. So first, let's compare the two graphs. If you compare the two graphs, the only difference in these two graphs is this open circle right there. The only difference between those two graphs. And then if we look at the functions themselves, what's the only difference with the functions? The functions is we canceled out this x minus 1, and that became that. All right, so if we cancel out a factor in a rational, the graph doesn't really change. All that really changes is we have this open circle at the place where we canceled out that factor. But when we're talking about limits, if we think about the limit at this value, the limit's not going to change because a single open circle is not going to change a limit value. So canceling out things is going to keep the limit the same. So all that's saying is we can cancel out problematic factors in a rational, and then once we cancel out stuff, then we can plug in our number. How do we cancel out stuff when we're dealing with rationals? We have to factor it and break it down into smaller pieces. All right, so let's say we want to actually do this limit now. We got 0 over 0 before, but this is the same as the limit as x approaches 3. I can factor the top, x squared minus 9. All right, knowing your difference of squares, that x squared minus y squared, can factor like this. All right, that comes up a lot. All right, so x squared minus 9 factors as x minus 3 times x plus 3 all over x minus 3. All right, then we can cancel out things that are on the top and bottom. So this is the same as the limit as x approaches 3. Again, the biggest mistake notationally that students make is not writing the limit every single time. It is tedious, but you kind of get used to it when you write it a million times. And now this is equal. When we cancel out factors, the limits are still equal because we just have a whole that doesn't change the limit. Now this expression, if I gave you this is just a polynomial. I plug in my number. And now that I've plugged in the number, the limit goes away because I've actually done the act of evaluating the limit. And that's 6. So the final answer for this one is the limit is 6. If you want to, you can go on Desmos, graph it, and just make sure that that makes sense. All right, same thing. First thing you'll always want to try with your limits is plug in the number. So if I try to plug in 3, I'm going to get 9 minus 9 on the top is 0. On the bottom, I'm going to get, 9 times 2 is 18, minus 15 minus 3, that's also 0. Right. So when you get 0 over 0, that's your clue that, okay, I might be able to cancel something out, or I should be able to cancel something out. So this is going to be the same as the limit. So that's your process 3. On the top, I'd say I can just pull out an x, that common factor between the two things on the top. I always look to see if you can just pull out a factor. That's always going to make the number smaller. On the bottom, I'm actually going to have to factor it. So if I have 2x squared minus 5x minus 3, right, factoring is something you should have practiced and be comfortable with, so I'm just going to do it really quickly. They need to multiply to negative 6, add to negative 5, so that's going to be negative 6 and positive 1. Pull out a 2, 2x. All right, so this is 2x plus 1 times x minus 3. All right, so that's going to go on the bottom of my fraction. And again, just like in the previous case, we want to look for things that cancel out. So we cancel out x minus 3s. And writing the limit every single time throughout this string of equations. And now the limit's going to disappear because now I have this rational where the bottom is not 0. So now I can plug in 3. Every single time you cancel a factor, try to plug in that number again. This gives me get 3 times 3 plus 1 is 3 over 7. So in this case, I get 3 over 7 as my final answer. All right, one more example. Limit as x approaches negative 3 of this. Again, first thing I always want to try to do when I'm plugging in or evaluating a limit is try to plug in the value. So I try to plug in the value. Let's get 9 on the top. 4 times negative 3 is negative 12 plus 3. That is 0. On the bottom, I get 9 minus 9. That's also 0. So I get 0 divided by 0. Tells me I should be able to factor. So this is going to be, let's see, multiply to 3, add to 4 is going to be 3 and 1. And we already saw how to factor the bottom. It's a difference of squares. I can cancel out the common factors. On the top, I have x plus 1 over x minus 3. And every single time you cancel out a factor, now I try to plug in negative 3 again. So if I plug in negative 3, the limit goes away because now I'm evaluating it by plugging in. I mean, negative 2 over negative 6, just positive 1/3. All right, so if you can factor, all right, first of all, the first thing you always want to do is plug in your value, make sure it's 0 over 0, and then factor. All right, so quick summary. Always start to evaluate a limit by trying to plug in the number. Because if you plug in the number and you get an answer, that's the answer. You don't have to do anything else. But when you get 0 over 0 for a rational, then you want to try to factor your rational and canceling. After you cancel out everything you can, plug in your value again, and then you should get a number for your limit. All right, so this is how to use factoring to evaluate a limit.